available for WAEC, NECO, JAMB, and the first year, second year students in higher institutions. It happens to be a question under friction. So let's read what the question says. It says a cast of mass 300 kilograms is drawn along a level floor. You take notes of the plane at which the cast was drawn on a level floor at a certain speed by means of a rope. The coefficient of friction between the cast and the floor is 0.35. So calculate the pulling force required when the rope is inclined at 15 degrees to the horizontal floor. Also find the angle of repose. So they gave us acceleration due to gravity as 10 meters per second square. So to answer this question, just think of a child who tied the rope on a toy car. So the child will be pulling the car with the rope with his hand above a certain height from the car. That is to say, the rope is always inclined between the hand of the child and the car. That is the situation we have here. We are pulling a cast of mass 300 kilograms with a rope inclined at 15 degrees to the horizontal. It's synonymous to a child pulling the car with a rope. So let's get that picture in mind. Let's use that to draw the diagram. So if this is the horizontal floor, it's always a rough surface. So let's indicate it as a rough surface. And let's say this is a cast now on this floor, and the mass of this cast is 300 kilograms. So what will now be the weight of this cast? The weight will be 3,000 Newton, because we know weight is mass of a body under the influence of gravity. So weight is always mg, mass under the influence of gravity. So with the weight acting downward, what we oppose this weight is normal reaction. So normal reaction is that force that opposes the weight of a body. So with this in mind, so let's assume the cast has a hold, something is holding the car, or a hook, and it's being drawn with a force. That force we don't know. So let's call the force T. Because the force that acts on the string or a rope is called tension. And it's inclined at 15 degrees to the horizontal. So though this is the horizontal plane, this plane and this plane are parallel to each other. So we can also take here as the horizontal plane. So as much as the cast is moving this way, there's a force that will oppose that direction of motion. We call that frictional force. Frictional force we choose to move in opposite direction. That was one of the basic laws of friction that says, one of them says frictional force oppose the direction of motion. So as the car is moving this way, frictional force we oppose it. So with this in mind, let's see how we can find the force and the angle of a repose. Then we're also given that the coefficient of friction, which is our mu, is 0.35. So if you look at the force on the rope, like I said, the force that acts on the string or a rope is called tension. The force acting on the rope is inclined at an angle of 15 degrees to the horizontal. So this force is neither vertical nor horizontal. Compared to normal reactions, it's completely vertical. Compared to the weight, it's completely horizontal, completely vertical as well. And compared to frictional force, completely horizontal. So the force on the string is neither vertical nor horizontal. For that reason, we are going to resolve that force into two components, vertical component and horizontal component. Although we've done such topic before under resolution of forces, you can still go back and watch how forces are resolved. So if I want to resolve this force now, we resolve it to the vertical, and we have T sine 15 degrees. So if I resolve the force to the horizontal, I will have T cos 15 degrees. So the force on the string now becomes a dummy force. We no longer have use for it because it has been resolved into vertical and horizontal components. So with that, we are having equilibrium force system, or a static body. And there are conditions for equilibrium or a static body. One of the conditions says that summation f of x equals to 0. What does that mean? Sum of all the forces acting horizontally is 0. So let's look at the diagram carefully, and it indicates forces that are acting horizontally. The first one is 15 cos t cos 15, and the second one is the frictional force. So we follow the principles of sign convention. We have done that also under resolution of forces. You can also go to my previous video and watch that. So the force here is positive, positive, negative, and negative. So this is the concept of sign convention. So if the arrow is acting to my right hand side, it's positive. If acting to my left hand side, it's negative. So if you look at the diagram, t cos theta is following this concept, which is positive, and frictional force is following this direction, which is negative. So the sum of all horizontal forces is 0. So let's do that. So I'm having t cos 15 degrees minus the frictional force equals to 0. So I can make the frictional force the subject formula by transferring it to this side. So my frictional force becomes t cos 15 degrees. So let's take this one as an equation 1. Why is it an equation? F and t, they are unknown. So we're having two unknown variables. So what is the second condition for equilibrium? It says that summation f of y is 0. So let's go back to the diagram and see forces that are acting vertically. A normal reaction is acting vertically. The 3000 weight is acting vertically. T sine theta is also acting vertically. So, but who are positive? You need to follow the concept of sign convention. So those acting upward are positive, while those acting downward are negative. So let's apply the summation of f of y. So my normal reaction is positive. My tension here is positive plus 15, while my weight here is negative minus 3000 is equals to 0. So I can transfer 3000 to this side. I'm having normal reaction plus t sine 15 degrees equals to 3000 Newton. Let's call this equation 2 because normal reaction and tension are unknown. So how do we solve equation 1 and 2 to get the force, which is the tension, acting on the rope? Let's recall under laws of friction that say frictional force is proportional or directly proportional to the normal reaction. So F proportional to arrow. So this one implies that my F is now mu arrow, where mu is the coefficient of static friction. And from the question, it's given to us as 0.35. So my F becomes 0.35 normal reaction. So let's also call this equation 3. So let's substitute arrow now from equation 2 into equation 3. So we can be left with the frictional force and tension. Let's substitute arrow into equation 2. And also substitute F from 1 into equation 3 also. So what are we saying in essence? We are substituting F and arrow from 1 and 2 into 3. So let's do that. So substitute F and arrow from 1 and 2 into 3. So from equation 2, my arrow is now 3000 minus t sine 15 degrees. From 1, my F is t cos 15 degrees. And from 3, F is 0.35 arrow. So let's substitute arrow in place of arrow, F in place of F. So this will give us t cos 15 equals to 0.35 into my arrow now is simply 3000 minus t sine 15 degrees. So let's open the bracket. We're going to have t cos 15 degrees equals to 3000 times 0.35. That will give us 1050. 0.35 times this, I'm going to have 0.35 t sine 15 degrees. So we calculate like terms from here by bringing t to this other side. So I'm having t cos 15 degrees plus 0.35 t sine 15 degrees is equals to 1050. So what is common from the left hand side is t. So I'm having t into cos 15 degrees plus 0.35 sine 15 degrees is equals to 1050. So let's make T the subject formula. So my T now is simply 1050 dividing cos 15 degrees for 0.35 sine 15 degrees. So if I sum the entire denominator, which is cos 15 degrees plus 0.35 sine 15, that will give us 1.0565. So this is giving us 1050 over 1.0565. So my tension is now 1050 divide 1.0565. We're going to have 993.8 Newton. So this is the force that is acting on the rope as the car is being pulled. So force is always measured in Newton, and the force that acts on the rope or a string is called tension. So instead of writing force, that's why I represented it with tension. By definition, tension is the force that acts on the string. So this is how to resolve friction when the body is being pulled at an angle inclined to the horizontal. Thank you for watching. Support our channel by subscribing.